Year 11 PPE February 2022. This is a calculator paper. First question. Inequalities. What's this describing? Well, x is greater than -1, but not including because of the open circle. We've got to show this on the number line, so put a circle at -3. And another one at 4. One of them is including and not the other. So the including one is the -3. So we shade that in. Okay. So that's the first one. And we join them with a straight line. Like that. Okay, next question. Highest common factor of 60 and 84. Quite easy this. Just take 60 and 84. You could probably do this without, but just to show the factor tree, we can have 30 and 2. So this is the prime factors. The 30 splits to 15 and 2, and the 15 goes to 5 and 3. Okay, do the same for the 84. We have 42 and 2. We also have 21 and 2, and then we have 7 and 3. Okay, pair them off. So a 2 and a 2 pair off, a 2 and that 2 pair off, and we have a 3 and a 3 that pair off. And they're the only pairs we can make. Normally we would put those on a Venn diagram, and we don't need to. We can see that they are 2 times 2 times 3, which is 12. That's the highest common factor of both of those numbers, 60 and 84. The lowest common multiple of these two, well, they're quite low numbers. You've got a calculator anyway, so just write the 24 times table. Okay, 24, 48, 72, 96, 120. You don't need to go any further because you can probably already see that 40, 80 and 120 is going to appear on here too. So the lowest common multiple is 120. Okay, is appearing on both of them. So you just need to make that clear in your answer there. Okay, so that's 4 marks there for those 2 parts. Next. Okay, so we've got some information here. This is a travel graph. This is the first part of the journey. We've got to work out Sam's speed. Well, he travels, or she travels 20 kilometers in 15 minutes. From 10 to 10:15. That's a quarter of an hour. So the distance, the speed rather, is the distance divided by the time taken, which is a quarter of an hour. Okay, so 20 divided by a quarter of an hour is 80 kilometers per hour. Okay, and that's it for the first part of the question. And then we go on to part B, which is asking us to, on this grid, to show the rest of the journey. Well, look, we've got 10 minutes of rest. So that's from here, that's 10:15 to 10:25. And then the final part of the journey, 20 minutes at 75 kilometers an hour. Okay, that's a third of an hour. So it's a third of 75. So it's a third of 75. Okay, which is going to be 25 kilometers covered. Okay, and it's going to do that in 20 minutes. So basically, I've just got to make this line go from where it is now at 20 kilometers. Another 25 will take us to 45, and another 20 minutes would take us to 10:45. So what I need to do is just put the line there, and I've got to go 20 along 20 minutes along and 25 kilometers up from where I am, which would take me to there. Okay, and that's it. Next question. Okay, fill in the numbers. Use the table function on the calculator, it's quicker. So you put f of x equals this function here and put the values of x in. If you do it manually, be careful, because you must put a minus sign round each negative number particularly. So it's -1 squared minus 2 lots of -1 plus 2, and that will give you this value here, and that comes to 5. Okay, if you put the 1 in, that will come to 1, the 2 in will come to 2, and the 4 in will give you 10. They're the 4 numbers that are missing. You have to then plot those points on your graph, so just plot them carefully. -2, 10 is up here, and then we come down to -1, 5, which is here. Then we come down to 0, 2, which is there, and then it's 1, 1, and then it's 2, 2, and then we go up to 3 and 5, and finally 4 and 10. If it's not symmetrical and smooth looking, then you've done something wrong. Now this is where I'm going to have a problem, because I've got to draw this using the pen and tablet, and it's really difficult, so it will be all over the place, but I'll do my best. I'll choose this color here. So it's quite a wide looking line, which might make it slightly easier for me to draw, but it's not going to look very good, so I'll do my best, but you will hopefully make yours look better. It must go through all the points and try and be a smooth curve. Okay, and well, surprisingly better than I thought it was going to be. Okay, well, there's my attempt at that with a very fat line. What I'm going to do now is, that will get me the next 2 marks. What I'm going to do finally is use it to find estimates for this equation solutions. Well, look, on the left I've got x squared minus 2x plus 2, which is what I've just drawn. I now need to draw the line y equals 4 on the same grid. So the line y equals 4 is this line here. And I just look at where my red line crosses the curve and estimate those solutions. Well, let's look at this one here. That's about minus 0.75, and this one is about 2.75. So all I need to do is just write those down. So x equals 0.75, okay, and x equals, sorry, that should be minus 0.75, and also x equals 2.75. Okay, they're estimates based on what I've done on the graph, but use your lines that you've drawn on the graph. Okay, that's probably closer to 2.7 actually, but that's fine. Okay, so next question. Okay, we've got to work out the perimeter of this shape. There's 5 parts to it. We've got 3 of them shown. What are the other 2? Well, it's this length here, which I'm going to call x, and this short little piece here, which I'm going to call y. Okay, so I've got x is going to be equal to the square root of 8 squared plus 10 squared, using Pythagoras' theorem. Okay, so that's the length that I've called x, the hypotenuse of the triangle. Okay, so that there is basically that length here. Okay, and to get y, that's actually taking off this part here, you see, is 10. Okay, because this is the base of this triangle, up to here is 10. So this bit y is that answer. So y is the length I've got there, which is x minus 10. Okay, because that value of x is a little bit more than 10. And then I've just got to add the 5 things together. So the total length is 8, the total perimeter, 8 plus 8 plus 10, okay, plus the square root of that, which by the way is the square root of 164, okay, and that simplifies further to give me 2 root 41, okay, because it's root 4 times root 41. So 2 root 41, okay, and the last bit, y, is equal to 2 root 41 minus 10. Okay, now you don't have to put brackets around any of this, but I'm just doing that and that just to show clearly the 5 different parts, the 3 numbers given plus that plus that. Put that in the calculator and you get 41.6 millimeters to 3 significant figures. Okay, and that's the answer to that. And it says at the bottom, give your answer to 3 significant figures. Okay, this is simple trigonometry here. So all we have to do is take look at this triangle. We've got to find the length of BC, which I'm just going to call x. And I can see that x is opposite the angle 56 and 12 is adjacent to it. So that means that must be the tan of 56. So therefore x is equal to 12 times the tan of 56. And if you put that onto the calculator, that will come out as the tan of 56 times that, and it gives me 17.8 centimeters. Okay, 17.8 centimeters to 3 significant figures. Okay, and the next part of the question is asking me to do the angle x, to work out the angle x, and I could say that the adjacent over hypotenuse, okay, so 15 over 18 is the adjacent over hypotenuse, which is the cosine of the angle x. Okay, so x is now the angle, you see. Therefore, x is the inverse cosine, shift cos on the calculator, of the fraction 15 over 18, and that will come out to be 33.6 degrees to 3 significant figures. Okay, and that's 3SF. Okay, now question 7 is also here, so we'll go straight on to that. Now question 7 is about these 2 liquids, and we just need to remember this. I'll just put this up here. Density is mass divided by volume. Okay, you usually see that in a little triangle. Okay, same sort of thing we use for speed, distance and time. Okay, and there it is. So that's that, and then we separate it out like that. Okay, so density is mass divided by volume, and what we've got to do here is work out the density of liquid C. So we need the total mass of C, okay, which is made of well, we know its density and we know its volume. So this is liquid A is 1.8 is the density of liquid A multiplied by its volume, which is 80. That will give me the mass of liquid A. The mass of liquid B is going to be 1.2 times its volume, which is 40. That comes to 192 grams. Okay, that's the total mass. The total volume is just going to be 80 plus 40. Okay, so the density of liquid C is going to be liquid C. The density, okay, is going to be 192 divided by, I'll just put it here, the volume is 80 plus 40 equals 120. This is my working. So it's going to be 192 divided by 120, and that's 1.6 grams per centimetre cubed. That's the density of liquid C. It's exact, okay? You don't need to round that or anything because it's exactly as it comes out. Okay, next question, and here we go. So this one is about a cumulative frequency. Lots of information. There's only 1 mark for this, and it says write down one thing that's wrong with the cumulative frequency table here. Well, basically these are the cumulative frequencies. So the 13 is 5 plus 8, the 25 is 5 plus 8 plus 12, and basically the 25 means everything from the beginning up to 30. So these numbers are wrong. They should all be zeros, and that's what's wrong with it. So all you need to say is inequalities. Okay, that's the things in this column here. Inequalities, okay, should begin with 0. If you put that, that's clear. Now, what we're doing is we're actually saying what should be in place, which is another way of saying what's wrong with it. So that's fine. You could give an example if you wanted to. You could put, for example, 20 less than t less than 30 should be, okay, and just put 0 less than t less than or equal to 30. So if you give an example, in fact you could just do that alone and that would be enough. So there's more than enough there to get that mark. Okay, next. This is a box plot and we've got to find the interquartile range. Read the scale really carefully, okay? This number here is the lower quartile and this number here is the upper quartile. And if you're really careful about that, you can see that that's actually 50, okay? And this is 188. Write those two numbers down, okay, because if you get the answer wrong they'll be looking for those numbers, and that comes to 138. It's the difference between the two. Okay, Becky says 50% of the people waited for at least 2 hours. Is she correct? Well, you've got to answer the question first, yes or no. So the answer is yes, she is correct, because the median, okay, is 50%, right? Which is, well, the median is halfway through the data. So the median is 120 minutes, okay, which is equal to 2 hours. And that's the reason. That's the best reason to give, the most obvious one. Now, Becky looks at some information about Tuesday, that's about Monday, and she was asked to compare the distributions, and she wrote, people had to wait longer on Tuesday than Monday. Give one reason why Becky may be wrong. See, we don't actually know if she's right or not from that data, but one reason, one obvious reason, is that the median, okay, on Tuesday, the median on Tuesday is equal to 100, and that is less than the median on Monday, which is equal to 120. And that is definitely all the information that you would need to put to get that answer. Okay, next. 2 investments here. Louise puts X pounds in better investments for 3 years, and at the end of it, it's worth that. So let's do that first, and then see how much she put in. In other words, what this X was. So I start with this amount of money X, And because I'm investing at this rate for 3 years, I multiply x by 1.025 cubed. Okay, and that will give me the amount after 3 years, which they're telling me is 344,605. Okay, so from that, x must be equal to 344,605 divided by 1.025 cubed. Okay, you don't need the bracket round that really. And that comes to a nice round number of exactly 320,000. Okay, so we now know that Sadiq puts that amount of money in and invests that for 3 years using the county bank. So for that investment, we start with 320,000. Okay, we first of all times it by 2% increase, which is 1.02 squared, and then times that by the 3.5% increase in the 3rd year, which is that. And when we put that in, we get the value of the investment, which comes out to be 344. So 344. Okay, 580.48. Okay, finish, and it finishes exactly there at the 2nd decimal place. So that is how much he has at the end of that investment. Okay, and that's the answer. A straight line graph. Okay, and we've got 2 points we're given. So from that we can get quite a lot of information. We've got to find the coordinates of this point R. And this is divided in the ratio 2 to 3. Okay, so this length here is 2, this length here is 3 in that ratio. Now what I'm going to do is draw 2 similar triangles, and you'll see the significance of this in a moment. So if I go from this point here to below R there, okay, like that, and then drop straight down to there. Okay, that triangle there and that one are similar, but this one is 1.5 times bigger than this one. Okay, so basically if this length along here is 6, okay, I'll just put these numbers in here. You can see that that length is 6. This length here must be 9. Okay, to keep that ratio. And this height here is 3, because it's going up from 0 to 3. This must be 4.5. Okay, so it's quite easy to see that the coordinates of R are, well, it's 9 along and a total of 7.5, because this bit here is 3. Okay, so if I just finish that diagram off like that, then I've got a 3 and a 4.5 added together to give me 7.5 as the y coordinate. So I can see that the coordinates of R are 9 and 7.5. Okay, and then I can go on to part B, find an equation for the line perpendicular to L. Now this line here, line L, has a gradient of a half, because for every 2 I go along, I go up 1. So for 6 along, I go up 3. That's a gradient of a half. Now a line that's perpendicular to it will have a gradient of the negative reciprocal of that, which is -2. Okay, so I'm just going to put that line in there, and this gradient here is -2. Okay, so the gradient is -2. Okay, well, a straight line with a gradient of -2, that's at 90 degrees like that, crosses the y-axis at 3, has an equation y equals -2x plus 3. Okay, next question, number 12. We have 3 brackets here to expand. So we start usually by leaving the left-hand one alone. So I'm going to write here x minus 2, and next to it the multiplication of the other pair of brackets using FOIL, first outer inner last. So 3x times 2x, 6x squared. Okay, that's the first. The outer will be 9x, the inner will be plus 4x, and the last terms, 2 times 3 is 6. Okay, combine those two middle terms to give me x minus 2 multiplied with 6x squared plus 13x plus 6. This time we have to do 3 multiplications with the x and then another 3 with the minus 2, and then simplified afterwards. So we're going to have basically all of these times by x, which are going to be 6x cubed plus 13x squared plus 6x, and then the same 3 terms multiplied by minus 2 instead. So we're having minus 12x squared, okay, minus 26x, and minus 12. Okay, now we just simplify that. 2 pairs of those terms will combine. We will have 6x cubed. In x squared, we're going to have 13 and minus 12, which is plus 1x squared. We don't write the 1, we just write that. We've got plus 6x and minus 26x, which is minus 20x, and we've got our minus 12 at the end. And that's a fully simplified expansion. Okay, it doesn't matter what order you do the brackets in, but we tend to keep them in the right order, but do the last pair first and then finish with that one. Okay, and that's 3 marks for that question. And next. Okay, next. 16 teachers in a school, 120 girls, 100 boys. 1 teacher, 1 girl, 1 boy are going to be chosen to represent the school. Work out the number of different ways this can happen. Really easy this. It's a simple combination problem of you want 16 teachers, and each one of those can be with any one of 120 girls and any one of 100 boys. And if you put that all into the calculator, you get 192,000 is the total number of combinations. Next, circle theorems. Find the size of angle SBA. First thing I do is mark the angle that I want to find. It's that one there, okay, SBA. And then use whatever circle theorems I need. Give a reason for each stage of your working. Okay, so let's try and do this fairly quickly. We know that BAD to BCD, the angles are in the ratio 3:1. So basically this angle here is 3 times this angle here. Okay, so I'm going to call this x and I'm going to call this 3x. Okay, now I know that 3x plus x equals 4x, but it also equals 180 degrees. Now that's important. I know that because it's opposite angles in a cyclic quadrilateral. Okay, and they always add to 180 degrees. So opposite angles, okay, cyclic quadrilateral. Okay, now it's really important that you do include those words, okay, because there are key words that you have to include, and it's opposite angles in a cyclic quadrilateral. Okay, and they sum to 180 degrees, but that's implied by what you've done here. Okay, so what I need to say here is that 4x is 180, therefore x is 45. Okay, so I can see that this angle 3x is actually 135, and this angle here, x, is 45. Okay, now I need to know what this angle here is in yellow. I could work this one out quite easily if I wanted to, but I don't need it, in fact. Because if this is 45 here, I know that the total angle here, the whole of that, is also 45. Okay, and that's because it's the alternate segment theorem. So what I'm going to do here is I'm going to say that angle SBD equals 45 degrees, and the reason I'm able to say that is it's the alternate segment theorem. Okay, so that's my reason that I must give to get the marks for this question. Okay, and therefore I can now say that my angle that I need in yellow, because I've marked everything clearly on the diagram, is going to be angle SBA, okay, which is going to simply be made of 45 minus the 20 that's already there, which is equal to 25 degrees. And that's it. Next question. Okay, we've got this triangle and we've got to find the length of the line BC. Okay, I'm just going to call that line X. Well, this is a cosine rule question, so basically substituting into the formula, we've got an angle, we know the two sides, either side of the angle, and we just got to find the one opposite. So it's very straightforward. X squared equals, now it's going to be 8 squared plus 11 squared minus 2 times 8 times 11 times the cosine of the angle between them, which is 72. Okay, set it out, show the working like that, and what I could actually do at this stage, save writing it all out again, is just take away the squared and square root the left-hand side, sorry, the right-hand side. So I'm just basically saying x is the square root of all of that. Okay, putting that on the calculator. So always show what you're putting onto the calculator, and then on the next line work that out, carefully typing it in to give you 11.4 centimeters. That comes to 3 significant figures. Okay, now a lot of the time these diagrams are not drawn to scale, so don't sort of go by what it appears to be. That's correct. Okay, now for part B, that was part A. So for part B, we have to find the area of the triangle. Well, again, this is straightforward. You use a half AB sine C, okay, where in this case C is X and A and B are the sides next to the 8 and the 11. So basically, we just say that the area, okay, is a half of 8 times 11 times the sine of 72. And on the calculator, that comes to 41.8 centimeters squared to 3 significant figures. Okay, that's it. Really quite straightforward. Next question. And here we have to do an iteration. Now, they're giving us an iteration formula to use. Okay, the next iteration is the cubed root of 10 minus twice the previous one. We've got to work out x1, x2, x3. This is what you do as a reminder. Go to the calculator and literally type into the calculator 2. then press the equals button. That stores the answer 2 in the calculator, and then go straight into typing this. So you put the cubed root symbol on the calculator, not the square root, the cubed root with a little 3 around it like that, and then you put in to the calculator 10 minus 2 times the answer, 10 minus 2 times, and then you literally press the ANS button. Now that's it, and that will give you, when you press equals once, it will give you the result of putting the x equals 2 into that equation. All right, so it will give you in fact 1.817 and then it goes on. Okay, and then the next one you press equals again, but be careful not to keep pressing it, just press it once at a time. That will give you x2, which is 8,533. Okay, and the next one is 8,462. Okay, 1.8462. It doesn't actually ask you to give it to any particular number of places, so I think that's sufficient enough to show that you're on the right track. And then unusually in this question, normally the iteration comes from an equation that you're trying to solve. This time they've given you the iteration and you've got to find what equation it came from. So what I'm doing is I'm considering this to be the equation that x equals the cubed root of, okay, 10 minus 2x. That's what it's come from, you see. Okay, so I'm just going to rearrange that to get a cubic equation, and then hopefully I can find the values of a and b. So if I cube both sides, I get x cubed equals 10 minus 2x. Now if I add 2x to both sides and subtract 10, it will give me x cubed minus, plus 2x minus 10 equals 0. And therefore, if I compare that with this, my a is 2 and my b is minus 10. And that's it. Okay, next. Number 17, a histogram. 20% of the people got a score high enough for them to qualify for the second round. We got to find what score 20% of the people got, the top 20% scores, okay, or the top 20% of people, what they scored. Well, we need to basically find the top 20% of this area. So let's work out the areas or the frequencies represented by each block. This is 5 times 0.8, which is 4. This is 10 times 1.6, which is 16. This is 10 wide times 2.2, which represents 22. And this is 15 times 1.2, which is 18. Add those together and we get a total of 60. Okay, so that means there were 60 people in this competition, and those 60 people, okay, we need to find what 20% of that is. That's 60. So 20% of 60, okay, you can do that in your head, is 12. So we've got to find where the top 12 people are. Well, if there's 18 people in this last block, it's very easy to see that 12 is 2/3 of them. Okay, there's not really a lot more you can do here than just show this with a little bit of supporting working. So I'm just going to put a line in there, and I can see the answer is going to be 30. To the problem, because basically I've got here, I'll just show you what working out you could put. So this here is an area of 18, and I got to basically find 12, which is the last 2/3. So I'm just going to show that 40 minus 25, so that's the length of this base, is 15. Okay, and then I'm going to say 12/18 of 15, okay, which is 2/3 of 15 is 10. Okay, and then I'm going to take the total number of people, 40, minus the 10 represented, the total score is 40, the highest score, minus the 10 will give me 30. Okay, it's almost easier just to see that from the drawings and diagram on there, but that's some supporting working as well. Okay, now in this question we've got to solve this equation relating to sine x between 0 and 360. So the sine of x is 0.6. So let's have a horizontal line at 0.6. Okay, and it will cross the sine graph twice, but then it's going to cross it again on its next cycle, because we've got to go up to 720 degrees and find all 4 solutions. So really it's a question of looking this up carefully and projecting down. Okay, so what we're really doing, I'll show you this in full, is we're just estimating what these crossing points are worth. It's not quite in the right place. Okay, it's a bit tricky on this device, but it's about there and about there. Okay, I'm reading those off, and basically you've got to try and read those as accurately as you can, and we're estimating that this one is a bit less than 40. It's about 30, looking like it's about 37 or 38. So I'm just going to put 37, okay, and the next one is going to be, it should be 180 minus 37, because it's symmetrical here and here, you see. This is like the line of symmetry at 90 degrees. So 37 and 143, okay, but then the sine graph just repeats itself every 360 degrees. So basically if I add 360 to these, I'm going to get 397, and add 360 to that, I'm going to get 503. So they're my estimates for the 4 values of x. Now I reflect the graph y equals sine x in the x-axis. Everything that's above becomes negative. So if it was 1, it's now minus 1. So basically the equation is simply y equals minus sine of x, and that's a reflection in the x-axis. And in this case here we've got a function f of x, and we've got to draw on the grid f of x minus 2. All right, so what that means is it moves it 2 places to the right. Okay, so if I just draw that in, it's like this. So that point there goes to here, so it has a base there like that. This has got the same gradient, which is 3 along and 2 up to there, and this part has the same gradient, 2 back and 2 up, like that. Okay, and next question. Okay, this is about volume, area, and linear scale factors and ratio. What I'm going to do here is we've got these 3 spheres, and I'm just going to make a little table which will explain what's going on. So sphere A, B, and C. Okay, and this is going to be the length, the area, and the volume. Okay, now if I just put the volume of A here, in this column. If I just put some lines down to make it clear. Okay, so we have this table here like that. So if I just take sphere A, we have its volume, and we also have that for B. So let's put that in first. So the volume of A was 125 and the volume of B was 27. Okay, now I'm going to cube root that to give me the ratio of the lengths. Okay, so the cube root of 27 is 3, the cube root of 125 is 5. So basically the lengths or the radiuses or any lengths in those spheres A and B are in the ratio 5:3. And ratio C is double the lengths of B. So the radius of sphere B to the radius of sphere C is 1:2. So if that's 3, this must be 6. Okay. Now, we're interested in the ratio of the surface area of sphere A to the surface area of sphere C. So we don't need to know what the surface area is, we just need the ratio of areas, any areas in those spheres. Well, if this is 5 and this is 125, this is 5 squared, which is 25. Okay, this one is 3 squared, which is 9. This one is 6 squared, which is 36. Okay, so that's all I need. I don't need this number. It would be 216, but we don't need it. We just need these two because it's the ratio of the surface area of sphere A to the surface area of sphere C. So the answer is 25 to 36. Okay, and my working out is very clearly shown in that table next to it. Okay, and the next question. And now this question about probability involves 3 successive events: Monday, Tuesday and Wednesday, whether it will rain or not. So if you did a tree diagram, it would have 3 levels and quite a lot of branches. You don't really need to do a tree diagram for this. You could just carefully pick out the relevant numbers. So basically, in general, if it rains on one day, the probability it rains the next day is 0.8, right? If it doesn't rain on one day, the probability it rains the next day is 0.6. But the weather forecast says on Monday, there's a 70% chance that it will rain, therefore 30% that it doesn't. We've got to work out an estimate for the probability that it will rain in the village on Wednesday. Now, this means that they're not really interested in what happened on Monday or Tuesday, but what must happen is it must rain on Wednesday. So let's look at how that could happen. Well, it could rain on the first day, okay, which is 0.7, and it could rain also on the second day, which is 0.8 probability, because if it rains on one day, the probability it rains the next day is 0.8, and it would have to rain on Wednesday because we are interested in when it rains on Wednesday. So that's one possible way that could happen. Or, so we put a plus sign, it could rain on Monday but not rain on Tuesday, okay, which would give me 0.2 probability, but rain on Wednesday, which makes the probability of raining on Wednesday now only 0.6, okay? And then I could say, well, the other possibilities are that on Monday it didn't rain, which was 0.3, but it did rain the next day, okay, and it did rain on Wednesday. And finally, I could have that it didn't rain on Monday, okay, and because it didn't rain on Monday, the probability that it doesn't rain on Tuesday is 0.4. Okay. And then the probability that it rains on Wednesday would be 0.6. There's the 4 ways that it could rain on Wednesday. Okay, the other 4 possibilities are for it not raining on Wednesday. So if we just add those up, that will give us the answer. And that comes to when it comes to 187 over 250, if you put that on the calculator. And that is also, as a decimal, 748 or 0.748. Okay. Now you can leave the answer as that, or if you like, as 74.8%. Okay. It doesn't ask for it in any particular form, so any of those will do. Okay. Last question. Quite a lot to do here. We have this formula, t equals 2 pi root L over G, about a pendulum. And these numbers L and T have been given to 3 significant figures. So we've got to find the upper and lower bounds of these figures first of all. So if I just do a little table where I put the values L and T, okay, and then I have for each one the lower bound and the upper bound. Okay, so let's just quickly establish what those could have been. So the lower bound of L, just finish this table off. Okay, so the lower bound of L, which is given to 3 significant figures to be that, could have been 51.95. And the upper bound could have been 52.05. Regarding T, the lower bound would have been 1.445 before it was rounded. It could have been as low as that, up to as high as 1.455. Okay, so that's the first thing you need. You also need to rearrange this equation because we've got to find the lower bound for the value of G. So what I'm going to do is just square both sides. T squared equals 2 pi all squared, which is 4 pi squared times L over G. Okay, if I multiply both sides by G and divide by T squared, I get G equals 4 pi squared L, okay, over T squared. So that's my rearranged formula. Now what I've got to do is find the upper and lower bounds of G. So to get the lower bound of G, okay, I need to minimize this fraction. That means I need the smallest possible numerator and the largest possible denominator. So that's going to be 4 pi squared times the smallest possible L, which is 51.95. Okay, and that's got to be divided by the largest possible T squared, which is going to be 1.455 squared. Okay, and you must show this working clearly, and that comes to 968.7669. Okay, and I'm now going to do the same for the upper bound, but this time I need to get the highest possible numerator. So it's 4 pi squared times the upper bound of the value of L, which is 52.05, and divide that by 1.445 squared. Put that on the calculator, and that will give me 984. Okay, 984.1125. Okay. Now it doesn't say anything about rounding them or showing them to any particular degree of accuracy. So I think in this case that's sufficient. You could round each one off to maybe 4 significant figures. So you could, if you like, put 968.8 and 984.1, but I think that's sufficient enough because your working is very clear. Okay, quite a difficult question on bounds, because not only did you have to work out all of that, you also had to rearrange the formula as well. Okay, and that's the end of that question and the paper.